Hi everyone and welcome to our electricity review. Congratulations, we've made it to the end of our unit, okay? And so we are going to be reviewing a few different lessons that we've had so far. So lesson 19, static electricity. Lesson 20, electric current. Those FET simulations related with good circuits and bad circuits, or like complete and incomplete circuits. Also, we will talk about conductors versus insulators, or I've called them non-conductors as well. Lesson 21 on series circuits, and then finally, lesson 22 on parallel circuits, okay? And so after you're done our review and watching this video and you feel comfortable, please do the quizzes assignment. You can click on this link right here and it will take you to a direct link. Remember to use your TDSB account to sign in, okay? So that's the review part. And then I'm just letting you know, I'm giving you a heads up, okay? So this won't be posted until a few days later, but our electricity culminating activity, it will also be on quizzes. It's going to be posted on the Google Classroom or else emailed in a few days, okay? So for this electricity culminating activity, I just wanted to remind everyone that students must work individually, so no help from parents or support people, okay? So you can, someone can read it to you, but if you remember, you can actually turn on the read aloud function so that even though there's no parents around, you can still read it aloud on your own, okay? And you will only be able to attempt the activity one time. So on all of our assignments so far, you were allowed to try it multiple times, okay? But on our culminating activity, we're gonna pretend just like it's like an exam or a final test, right? Where you don't get to try over and over and over again. By now, by the time you do this activity, your information should be pretty clear and you'll just try it once, okay? Anyways, I'll give you a little bit of an update anyways on that in a few days anyways, okay? Okay, let's get started. So the first topic in electricity that we talked about was static electricity, okay? And just a reminder that static electricity is electricity that does not move along a path, okay? So this is what makes things stick together when there's two items and they're rubbed together. To be honest, this type of electricity is not very useful. It just makes things stick together mostly, okay? So, over here, we have a picture of an atom. There's protons, neutrons, and electrons, okay? So these electrons are very lightweight, and if an atom loses electrons, like it kind of, you know, this electron goes to another item, or if something else gives up the electrons and it has additional electrons, then it becomes charged, okay? So if you have more negatives, it means you're negative. If you have more pluses, then you are positive, okay? So how does this happen? This happens through friction, okay? So when things rub together. Okay, so for example, and we've seen all these examples basically before. Okay, so let's just say you have your hair and you also have a brush. Both of these originally had three protons and three electrons. Three protons, three electrons, okay? They're totally balanced. They're equal because it's 3 plus, 3 negative. Overall, there's a charge of 0 and 0. But when you apply friction or when you rub it together, meaning that maybe you comb your hair, for example, notice that the electrons jump over, okay, so they jump over to the comb. Okay, and so what happens is that overall there's a positive charge on the hair, and over here, if I were to count this, there's 1, 2, 3, 4, 5 minuses, and there's only 3 pluses. That means that overall there's a charge of positive 2, okay? Because this is positive and this is negative, what will happen is that there will be an attraction, okay? So here are some rules that you want to remind yourself of. Okay, and it's that opposites attract. So if something is positive and another thing is negative, they will actually stick together. Okay, attracting means that they get very close to each other, which is why they're close together here. Okay, repel means that they're far apart. They push away from each other. Just like two magnets that when you hold North Pole and North, North and North together, they push apart. There's a force of repulsion. Okay, so they repel. Another thing that happens is that plus charge and neutral and also a minus charge and a neutral. This means that charged objects, whether it's positive or negative, they will attract with a neutral object. Okay, a neutral object is just like this right here, where it has a 0 charge because overall the charges are balanced. Okay, as I mentioned, like charges repel. That means if you have a plus and plus, they will push away from each other. So there's going to be a force that pushes that way and a force that pushes that way. Okay, same thing with minus and minus. There's going to be a force pushing these two negative charges away from each other. Okay, that's called repelling. Okay, that sums up static electricity. Okay, let's move on. Lesson number 20 was on electric current, okay? So this is electric current is electricity that flows along the path. So static electricity was like, you know, for example, rubbing your hair on a balloon, picking up these little pieces of paper, okay? Current electricity goes along in a circuit, right? And it flows along a path. So just remember that metal needs to touch metal to form a complete circuit, okay? So the metal is touching the bulb has a filament, there's a wire going through, the wire makes contact with this wire here. This wire makes contact with the positive terminal. In here, there's a reaction. There's a casing. The metal makes contact with the metal right here. Okay? Okay, another reminder, in a battery, the electrons flow from the negative terminal, that means it's the flat side, okay, so the negative side, and it flows along this way and it returns back to the positive terminal. Okay, so that's a question that will often be asked. Okay. In this section, we also learned about the different electrical symbols, so you'll have to know this as well, okay? So we are pretty good with this. The only thing, I don't think we're going to talk about this one so much, just letting you know, okay? And then this one, we usually make this a little bit different, so it just looks like this, and then an open, okay? So you might put like 2 dots around here. Okay, so please realize, everyone, you don't have these handouts. I hope you've realized that now, okay? So you don't have these handouts, but we're just reviewing the stuff that was in the handouts, all in one page here, okay? So, sorry, this is my fault. This is actually a closed circuit, so it's actually supposed to look like this, right? So you put a dot, and then, oops, sorry. Okay, so this is a closed circuit, okay? Okay, let's keep going. So you will need to memorize these. Okay. Okay, next up over here. This is a situation where we have an open circuit. So all the metal is touching. However, this thing right here is open. Right over here, this metal is not making contact with this metal. Just be careful because it kind of looks like there's gaps here, but there isn't supposed to be. I just found that this picture is very clear, okay? So I wanted to keep it. So over here, they have open switches. So the electrons are not moving. It means it's incomplete, which means there's no electricity, okay? So open switch, open circuit means that the electrons are not moving and there's no electricity. Okay, over here we have a picture of when this is a complete circuit. So you have the negative terminal over here. It goes around here. Everything is making contact. Okay, there's a closed switch here. Making contact with everything over here. It forms one complete loop. That means that the electrons are moving. The circuit is complete. That means that you will have electricity. Okay, so that's lesson number 20 on electric current. Okay, then we talked about complete or good circuits versus incomplete or bad circuits. Okay, and I'm putting them in quotes because like they're not like good and bad necessarily, but I think you get what I mean. Okay, so if you remember, we did the PhET simulation. So if you want to practice this, feel free just to practice making these circuits again. Okay, so here are some examples of complete circuits. So this is the most simple type. There's a wire, there's a bulb, and there's some batteries. Okay, everything is touching. Okay, here similarly everything is touching, but you'll notice that right over here there's a switch and it's closed. Okay, so these are complete circuits and the lights are on. Okay, next up, here are some examples of incomplete circuits. So over here we have an open switch, okay? So when the switch is open, the metal is not making contact with the metal. That means that the circuit is incomplete and the light bulb doesn't light up, okay? Similarly over here, okay, everything is making contact, but take a look at this, right? Here we have plus, plus, and the negatives on the outside, okay? We have to have, so on this side would be plus, this is the negative end of the battery, plus, and then the negative, okay? So when it's flat, it's negative. Positive is where there's a little nub, okay? So in order for there to be a complete circuit also, there has to be negative and positive touching each other, okay? So it cannot be like this, okay? Okay, next up. We also talked about conductors versus insulators. Okay, so we've got 5 electrical conductors. So all of these are metals. Okay, so generally metals are conductors. Okay, and then non-metals are electrical insulators. Okay, and so rubber, glass, oil, diamond, or dry wood. Okay, and then if you remember, we tested this by we tested on FET by using different items here. If the light bulb turned on, it means that the item itself is conductive. If the light bulb did not turn on, it means that the item was not conductive. So in this case here, there was a dollar bill or a paper bill. Paper is not conductive, which means that it will not turn it on. Okay, the next lesson that we did. Okay, so in series circuits, just remember that there's only one path for the electrons to flow. So if you trace the path from the negative terminal, the electrons flow through here, and then they go back, and it completes the circuit. But notice that there's only one loop. Same thing over here, okay? It would start off over here. It would go from the negative, go through the bulbs. Everything is making contact. Sorry, just pretend that this switch is closed, okay? It goes through like this. Notice that even though there's 2 devices, this only forms one loop. So the electrons don't have a choice in where to go. They have to go through the loop to return back to the battery, okay? So what are some characteristics of a series circuit? So the first thing is that the devices are either all on or all off, okay? So they can't be controlled individually, okay? So please notice over here that this is a series circuit, right? So they would go through here, they'd go through all these light bulbs, okay? And it would return back over to here, okay? Now, they are all on when all the devices work properly and there's no breaks in the circuit, okay? So over here, notice that they all turn off. So it doesn't matter that even though the electrons exit through here, which is the negative side of the terminal, okay? Notice that the electrons, even though they could maybe go through here first, the fact that there's a break in the circuit right here means that there is absolutely no electron flow, okay? That is why all of them are off, okay? Hope that makes sense. Okay, let's just keep going here. Okay, so this is definitely a disadvantage of a series circuit. So they're either all on or all off. There's no in between. Okay. The other disadvantage, so there's 2 disadvantages to the series circuits, right? The devices share electrical pressure, right? So that means that the brightness is affected. So let's see here. Here there's 2 batteries with 1 light bulb. Here there's 2 batteries, but there's 1, 2, 3, 4, 5, 6, 7 light bulbs, okay? So if there's only 1 bulb in a series circuit, then it gets the full electrical pressure and it's very, very bright. But if everything is all in one loop, so please make note of this, right? There's only one loop. The electrons have no choice in where to go. If they want to flow, they have to go through every single device here, okay? It's not that there's 7 different paths because there's 7 light bulbs. The electrons have no choice to go. They have to go in one loop here, okay? One circle or one, weird shape, but there's only one loop, okay? So they all get dimmer because they share electrical pressure. This is definitely a disadvantage. These are both disadvantages, right, to having series circuits, okay? So sharing electrical pressure and devices being all on or all off, they can't be controlled individually. Okay, we're almost there, last one. So lesson 22, parallel circuits. So in a parallel circuit, electrons actually have a choice in where to go, okay? So over here is the negative terminal. So take a look here. It can either go through here and go through the first light bulb and return, or it can go through the second loop right over here, okay, and return. So there's actually two paths here, okay? You could actually put in a third one here. If there was a third one, you know, it would kind of go like through here, if that makes sense, okay? You can even put a fourth one, a fifth one, okay? So I'm just gonna get rid of that though. Okay, so there's actually two paths to follow. Okay, next up. So these are some advantages, right, to parallel circuits. So if you remember in a series circuit, if you added more bulbs, they get dimmer as you add more. But take a look here. In a parallel circuit, the brightness remains the same, even as if you only had one light bulb, okay? So they don't share the electrical pressure. This is really important, right? You don't want your house to get dimmer and dimmer and dimmer every single time you turn on another set of lights, or, you know, run the TV or run your microwave. Okay, next up, the other advantage to a parallel circuit is that you can control different devices individually. Okay, so over here, in a series circuit, right, you have 3 light bulbs with 2 batteries. Here, you have 2 batteries and 3 light bulbs as well, but notice that there's different loops, right? So over here, you have one loop over here, then you have another loop over here, and then you have another loop over here, right? So they are on 3 individual loops. Notice that because they are on 3 individual loops, even though there's a break in the circuit here, notice that this light bulb is off, right? It's not working, but that's okay. Notice that the other ones are still working, okay? This was from our Google PhET simulation, okay? Sorry, not Google PhET simulation, PhET simulation. Over here, the electrons can't flow, right? Because there's a break in the circuit. So nothing is on here, right? Nothing is on because this is a series circuit and there's only one path, okay? This is really important, obviously, okay? Okay, so everyone, that's it. We are pretty much, that's it for electricity, okay? So I want you, after reviewing, if you want to watch this video once or twice, or it's like 17 minutes long, but once you're done that, you can click on this link. It will take you directly to the quizzes assignment, the electricity review assignment, okay? In a few days' time, I will send you the link for the electricity culminating activity. Please remember, you will only be able to do this one time, so make sure you feel really comfortable with the electricity review assignment first. Then, when this becomes available and you feel comfortable, only then should you try the electricity culminating activity. Okay, take care everyone. Good luck on the assignments and give yourselves a pat on the back. You're doing really, really well. Okay, take care everyone. Bye-bye.